Modeling and Simulation of Communication Systems lab, what we are going to do is the different types of keying. The basic goal of keying is to transmit digital data over analog channels. When we have to represent a digital message in the form of an analog waveform, we use the term keying. There are several techniques for keying, which include phase shift keying, frequency shift keying, and amplitude shift keying. Now we are considering the BASK or the binary amplitude shift keying. Here, the amplitude of the carrier signal is varied according to the amplitude of the information signal. The components used here are the CD4016, which is a quad bilateral switch, the 741, which is an operational amplifier, which acts as a non-inverting amplifier here, and the 7404, which is a NOT gate. Here, when the clock is 1, we get a signal of particular amplitude, and when the clock is 0, we get a signal of another amplitude. Thus, in the output we obtain, for clock is 1 and clock is 0, we get signals of different amplitude. Here we can see the circuit diagram of a BASK, that is binary amplitude shift keying. The circuit diagram is almost same as that of BPSK. The only difference is that here the 741, which is the operational amplifier, acts as a non-inverting amplifier. Thus at the output we get signals of different amplitude and same frequency.
We have now obtained the output for the amplitude shift keying experiment. Like we discussed with amplitude shift keying, when the input signal is high, the output signal will have a higher amplitude due to the amplification action of the op-amp. When the input is low, we get a signal of lower amplitude but the same frequency, which can be easily observed with the output we have obtained. The fact that the frequency of the modulating signal has no effect on the frequency of the modulated signal is also clearly demonstrated.
Now coming to BPSK or binary phase shift keying, here the phase of the carrier signal is varied according to the amplitude of the information signal, which is in the form of ones and zeros. Here also the same components as in the case of BASK are used, but the 741 here acts as an inverting amplifier. When the clock is 1, we get a signal of particular phase, and when the clock is 0, we get a signal which is 180 degree out of phase. The non-inverting amplifier provides this 180 degree phase shift. Here we can see the basic circuit diagram of a BPSK, binary phase shift keying. Here we can see that the clock signal is given to the 7404, which is the NOT gate. The input signal is given to the 741, which is the operational amplifier, here which it acts as the inverting amplifier. When the clock signal is 1, we can see that the phase shifted signal comes at the output, and when the clock signal is 0, the non-phase shifted signal comes at the output.
The output for a BPSK modulated signal can be seen on the screen. As can be seen, there is a phase shift of 180 degree in the output signal for each transition of the input signal. Also note that the amplitude and frequency of the output signal remains the same throughout. In our setup, the phase shifting action has been obtained by using an op-amp in its inverting mode.
Next, coming to BFSK or binary frequency shift keying. It is a form of modulation in which the frequency of the carrier is varied according to the amplitude of the modulating signal. The circuit is very simple. It consists of a CD4016 and the 7404 IC. When clock is equal to 1, we get a signal of particular frequency, and when clock is equal to 0, we get a signal of another frequency. Here we can see the basic circuit diagram of a BFSK. Here, when the clock is 1, we get a signal of particular frequency, and when the clock is 0, we get a signal of another frequency. The frequency will be different and the amplitude will be same.
We have now successfully implemented a BFSK modulating circuit. Like we discussed earlier, in BFSK modulation, the frequency of the carrier signal is varied in accordance with the amplitude of the modulating signal. In our experiment, the shift in frequency has been achieved by using a switching mechanism. By feeding carrier signals of different frequencies to two different switches, we have managed to successfully implement the BFSK modulation scheme.